Okay, this is going to be a lot quicker than the classroom version, which is going to last about a day and a half on the notes and about half the time tomorrow working on homework. First thing I'd like you to do, make sure you have a graphing calculator. Press pause if you need to go get one, whatever you got to do, whether it's on your Chromebook or whatnot, because I'm going to ask you to use it to do a few things. First of all, we got to recognize that in our graphing calculator there's a difference between being in degrees and being in radians. If you go to the mode button and about, I don't know, second or third line down it says radians, degrees. We're going to be in degrees for some of this, we're going to be in radians for some of this, but radians mostly, and I'll get to that. That radians is that stuff with the pi and so on. So what do I want you to do here? I want you to take your graphing calculator, press pause a minute, and find the value of all of these. Make sure your calculator is in degrees, and go from there. Again, plug in all those values. Press pause. I get these directly from the unit circle. If you think of the unit circle like this, the sine is the y value. This is 1, 0. So at 0 the value is 0, and at 360 the value is 0. Here at 90, of course, the value is 1. Here at 180, oops, excuse me, it's not that, it's 0. And here at 270, it's -1. That's how I'm getting those values. You also need Chromebook here. Actually, you really don't need any of this. We're just going to use these graphing calculators in class. In radians, this is 0 radians. This is pi over 2 radians. That equals 1. This is pi radians, which it also equals 0. This is sine of 3 pi over 2 radians, which also equals -1. And this is sine of 2 pi radians, which is still 0. Okay? So I'm just replacing 90, 180, 270, and 360 with those values. Go back to, so that was in radians. If we're not in degrees still, go back to degrees, and I want you to find all of these values. I'd have you do it in class. Literally plug in sine of 30 equals and so on. I'll give you the first one. It's 0.5. Okay, which we should know that because if we think about again of that point that's like right here, it was further over than it is up, so the y value is the 1/2 and the sine value would be square root of 3 over 2. We're going to get those values here, but I actually want you to see them as decimal values right now. Plug that in, press pause, plug each of these into your calculator. Now, why am I asking you to do this? Well, what I'm trying to get across to you is as we're on the upper half, so from 0 to 180, the values increase and then they decrease. So they increase to 90 degrees, which is 1, we said that before. Then they decrease back to 0, which makes sense, up to 90 degrees, back down to the 0. And then they decrease to -1 at 270, and then keep going up towards 0 from there. So all values, all positive between 0 and 180, okay? And all values are negative between 180 and 360. And then of course there's 0, well we already said that up above, at 0, 180, and 360. And again, these are all in degrees. So we're going to go graph this, okay? I'm here to tell you, we remember that the radius of this is 1 because each one of these points, 1, 0, 0, 1, -1, 0, and 0, -1. And again, remember, we're taking the sine value, so that's the y values at each one of these. And I'm going to make my amplitude be 1, so from 1 to -1. And so I'm going to answer that right now. And I'm going to put, on every one of these graphs, I'm just going to put 4 bars, okay? That's going to be the length. So I'm going to go to the end, I'm going to go to the middle, and I'm going to try and split the difference between the two. I'm trying to get it as accurate as possible in terms of the length between tick marks. Now where do I start? Well, each one of these represents 90 degrees. So this is 90, this is 180, this is 270, this is 360. We're just using these values that we got right up here on the top. Okay? Make sure you can see what I'm pointing at. Yep, okay. So at 0, it is 0. At 90 degrees, it is 1. At 180, it's 0. At 270, it's -1. And at 360, it's 0. Again, I just graphing those points really. And you can see what this looks like. Now you should have already seen this if you did your homework that was due today. Anyways, what's the period? Well, the period one full cycle from top all the way down to where it starts again is 360 degrees. Okay? So that's in degrees, but now everything else is really going to be in radians. We're going to start kind of like this tomorrow with cosine as well, or excuse me, 2 days from now. But the same thing can be said in radians, okay? And I wrote up above, right here, what each radians is. 0, pi over 2, pi, 3 pi over 2, 2 pi. You can see that right on your unit circle from section trig 12, or trig, I think it was 8 actually. Now, the rest of these points, again, the same points as I used up above, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. But in radians is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that when I go to do my drawing, the unit circle still has an amplitude of 1. That nothing changed there. I'm still going to put 4 bars, so split it, split it, split it. And I'm going to put these measurements on there. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to graph the points the same. And if you remember up above, we said that those values right below 0, 90, 180 are equivalent to it. So I start at 0, and you'll see that whether I do it in degrees or in radians, you get exactly the same graph. And I have a song for you to remember it. You all remember the song last year, Bruno Mars, Uptown Funk. And the way the song goes is uptown funk you up, uptown funk you up. Say what? And then if you apply it to this, you know that sine always starts at 0. Look at each of these graphs. Sine always starts at 0. Cosine starts at one of the other 2 points, but that's not what we're doing today. Sine always starts at 0. And then I go up, down, down, and up, down, down, and up. Say what? See? You'll remember that. I know Sirius was being stupid. The period here is 2 pi, and I'm going to say that over and over and over here. Now, what you'll see here is the equation of sine of any general sine function, where a is the amplitude, and if we take the amplitude, it's a distance, so it's never negative. That's why it's absolute value, even if there's a negative number there. And then the period can always be found, let's circle this, by using that b right there, okay, and plugging it in by just taking 2 pi over b. Again, up, down, write it, down, and up, down, down, and up. Say what? All right, yeah, okay. Let's move on. Next page. Now we're going to start actually seeing what these are. Let's graph a few of these. On the first one, the example is y equals 3 sine of theta. Now, a couple of reminders. Let's maybe write this over on the right side here. The general equation is a equals b sine of bx, okay, or b theta. You can just replace all these thetas with x's in all of these problems. What you'll know is, first of all, the period can always be found by taking 2 pi over b. And when I say draw 4 bars for each one of these graphs, you're always going to put your period at the end, and you're always going to put half of your period in the middle. And that's all I need you to label, okay, just so I know you know what you're talking about. We know that the amplitude is equivalent to the absolute value of a, always positive because it's a distance, okay? We're always going to graph 4 bars on every graph, 4 bars this way. We're going to put 1 bar each way going up and down, just so everybody's kind of looks the same. It's easy for me to grade, it's easy for you to do. Always label the period, and mid period. I'm making that word up, it's not really a word, but basically divide the period by 2 to get that number. So what do I know here in example 1? I know that my a, because it's the number that's in front of the sign, is my amplitude. A is 3, so my amplitude is 3. The only reason I'm having to do that twice is because if that's negative, the amplitude is still positive. B here, well, what number is next to x? Well, when there's nothing there, it's not 0, because 0 would make it go away. It's 1. So the period can be found, again, by taking 2 pi divided by b, and 2 pi divided by 1 is just 2 pi. So when I go to graph this, I'm going to put my bar in each direction. What number goes here? Well, it's the amplitude. That's how high and how low our graph is going to go. I put a bar all the way at the end, half, split it. All the way at the end is where I put my period. This becomes really easy, because what's half of 2 pi? Half of 2 would be 1. So we'll put pi here, or 1 pi if you want to write that, that's fine. And then the cool thing about this is everything else works the same. Where do all of these sine graphs start? They start at 0. And then we go up, down, down and up, down and up. Okay, so there's my graph. Done. Now I didn't continue to go through that like I should have, but you get what I'm doing. And it always works that way. Watch this. Next problem. This is one that we would do together. What is the A? What is the amplitude? What is the number in front of sine? There's nothing there, so that means 1. Again, it's not 0, because 0 times anything would make it go away. The amplitude then is 1. What is my B? My B is 2, so my period is 2 pi over 2. Those cancel, and I just get my period of pi. Again, we put pi at the end, because that's the period. Half of pi is literally pi over 2. Split the both of them. On the y-axis, we're going to put our amplitude and its opposite. And then, it's just like I've been singing all along. We start at 0, and we go up, down, and up, down, and up. And that's the sine graph. Done. Okay, it's that easy. So, what if I said here, though, instead of going to pi, if I said to go to 2 pi, what would you do? Well, you do the same thing, and then just repeat the pattern one more time, because they would have a period of pi. Okay, this is one that I would have you us do together. The amplitude here you can see is in front here is -1/2. That's good. So the amplitude itself, again, the amplitude's always positive. That tells me, you know what, I can go right to my graph right away and do that. Put my 4 bars out here, split it. Okay. The B here is, well, that's hard to see. X over 4 is the same thing as 1x over 4, which is the same thing as 1/4 times x. So it's hard to see, but our B here is 1/4. Okay. How do I find my period? I go 2 pi divided by B, and 2 pi divided by 1/4. You may not see it, but if I rewrite this as 2 pi divided by 1/4 and put this over 1, it becomes a keep it, change it, flip it. So 2 pi over 1 times 4 over 1 equals 8 pi, and that, ladies and gentlemen, is your period. Okay? So put that at the end, split it in half to put it here, and it is up, down, and up. It always starts at 0, but wait, it's not up, down, and up. Okay, I could plug values in here to show you this, where I would take, let's say, plug in 4 pi. Well, that we know is 0, because look at all these other graphs. This is going to be 0, and this is going to be 0. It just always works that way. Now, the other part of this is, I don't go up, down, and up because of that little negative sign. What do you think that does? Well, let's check it. If I plug in this point here, which of course halfway between there would be 2 pi, I go -1/2 sine of 2 pi over 4, which is -1/2 of sine of pi over 2, right? And sine of pi over 2, we said on the previous page that sine of pi over 2 up at the top of the unit circle is 1. So this is -1/2 times 1, which is -1/2. So at this, it goes down here. Why? Again, really the short answer is because it's -a. And so at the next point, at 6 pi, if I put a 6 in here instead, and that becomes a 3 pi over 2, then I would have -1/2 times -1, which is +1/2. Well, that's up here. So here we're going down, up and down, up and down. Now that doesn't have the same ring to it, so maybe we don't even say that. But just know that if there's a -a, the whole graph just flips. That's it. Okay. In fact, we're going to put that here. So a -a flips the graph upside down. Okay. Now, what I would ask you to do from here is we're going to go down below. I'm going to do A for you. Make sure that this is on the camera. All right. A is my amplitude, so I know I have 3 and then sine because they're all in that y equals a times sine of bx form. Okay. All the graphs should look the same here, right? So I could go right away, and again, I could put 3 and -3. I know I start at 0, 4 bars. I know that I'm going to go up, down, and up. I know my period. It's telling me my period. My period is 3 pi. So before I finish any of this, I can go graph that, and then if I want to put 1.5 pi or 3 pi over 2, same thing, and I would go up, down, down, and up. I could go graph all of these problems right now because I know they're all going to go up, down, and up, like Bruno Mars says. So what about the rest of these? Let me just start them off. 1/2 times sine. What do you think I write here? 1.5 times sine. Now the period, this is where we get in trouble. You know what? Let's just graph all these. I could literally just graph all these because I know they start at 0. I know what the amplitude is because it's telling me. I know that I got to go 4 bars. Look how easy this is. And I know that the period is at the end. So half pi goes out here. What's half of a half? Think of money. What's half of a half dollar? A quarter, yes. So 1/4 pi would go there. And pi over 6, what's half of that? Well, if I take 6 pieces of pizza and I split those in half, how many will I have? I'll have 12. Half. Yeah, that sounds kind of confusing, but basically, take the denominator times it by 2. Take the denominator times it by 2. Even this one, if I have 3 over 1, take the denominator times it by 2, I'd get 3 over 2, which is 1.5. Now again, they're all up, down, and up. Up, down, and up. Boom. Boom. So I got my graph done. I got part of my equation done. All of these are good to go. The only thing I'm missing, by the way, why do I know it's all up, down, and up? Because I'm assuming a is greater than 0. So I'm not assuming that any of these a's are negative, and that's the way it's going to be on the test. That's the way it's going to be anywhere I ask you to do this. Okay? Now the period. I know the period is 2 pi over b. I don't know what b is, but I know what my period is, so I can find it. I can set that equal to 3 pi because that's what the period is, right? Over 1, and then cross multiply and divide. So here I'm going to have 3 pi b equals 2 pi. I got to solve for b, so what am I getting rid of here is 3 pi. It's always going to work this way. The pi's will cancel. There's my b, because these cancel too. 2/3 x. That's all I got to do. There's my equation. Okay, show it again. 2 pi over b equals the pi, equals the period, which is 1/2 pi, which is pi over 2. Cross multiply, b pi equals 4 pi, and divide by pi. You can see my answer, b equals 4. Done. Same thing here, pi over 6 equals 2 pi over b, so you could solve it either way. Cross cancel, 12 pi equals pi b. And it seems big, but that's okay. As long as my math works out, that's the way it is, 12x. And that is the answer, okay? Don't let it get confusing. You can see the graphs are all exactly the same. The period goes at the end for all of these, this whole page through. Half of that goes in the middle, like that for all of these. The amplitude goes on the top and bottom of the y-axis to show where my points go. And then it's up, down, and up. And the only time that changes is like in this one when I have a negative a. Okay? Let's go to the next page. Now we're going to take a look at seeing if we can identify what is the amplitude, what is the period, and what is my equation from there. The amplitude, again, is from the midline up or the midline down, or from top minus bottom divided by 2. 2 minus negative 2 divided by 2 gives me 4 over 2, which is 2. The period is from top to top or bottom to bottom, or from beginning of the cycle to the end of the cycle. And this one is the toughest one on here by far to see. If you see that this bar goes in 1, 2, 3/3, right? 3 over 3 is pi. And 2 of those bars is what makes up my period, then you can see is 2/3. And that is just ugly. But what I do know is it's 2 sine because my period, my amplitude is 2. I need to figure out what my b is. Well, I can do that because I know that 2 pi over b is what the period is, 2 over 3. Cross multiply, 2b equals 6 pi, and divide both sides by 2 to solve for my b. I end up with 3 pi, and I just throw the x on the end like I did on the other page. Okay. You should really try these other two, and I'll keep in mind this one keeps going all the way to another. That's only half of the picture here, and that is 2 pi. So if that's half the picture, what's the entire picture? Think about that. Try this one, try that one. Press pause a minute. Try them on your own. Okay, so the amplitude, it goes up to 1. It's going to go down to -1, so the amplitude is 1. Again, 1 minus -1 over 2 becomes 2 over 2 is how I get there. The period, if this is half of it to 2 pi, then the other half would bring me to 4 pi. Again, I got 1 if you want to put that, or just sine. Got to find out what my b is. 4 pi over 1 equals 2 pi over b. Cross multiply and divide. Those cancel. The pi's cancel, and that is a fraction. It is not 2. 2 divided by 4 reduces to 1/2 x. Okay. Amplitude here, careful, it's going up by 1, so 1, 2, 3. 1, 2, 3, 3 minus -3 becomes a plus. 6 over 3, 6 over 2, excuse me, is 3. The period starts and ends between pi and y equals, again, 3 sine, set it up, pi over 1, 2 pi over b, pi b equals 2 pi, and divide, and you get that equation. Okay, they're all a little bit different. Some's got amplitude, some doesn't. Well, the amplitude is 1. They all have amplitudes. Let's go to the last one here. Similar. 2, -2 gives me an amplitude of 2. Period here starts at 0, ends at 2. Some of you like that when it's nice numbers and not radians, but the period is indeed 2. So I get 2 sine of, well, set 2 over 1 equals 2 pi over b. Just realizing maybe you can't see what I'm doing. Oh, yeah. Okay, and then cross multiply. 2 pi equals 2b. Divide both sides by 2, and you get pi x. And you can get a pi in there like you did on these, which I did wrong. No, I didn't. No, I didn't. We're good. We're good. We're good. All right. So this one too. We're good all the way through. The period is 2 pi over 3, or 2/3 pi. That's what I did wrong. Up here, this should be 2 pi. This is in pi, in radians. Duh. So I put a pi there. I put a pi there. And when I divide by those, that cancels out. So this is really just 3x. I'm sorry, I messed that up. I had to go back and rewrite it. It is, watch up here again, that's 2 pi over 3. So 2 or 2/3 pi as your period. So when I plug it in, the pi's will cancel each other out to get there. So again, if these are all in radians, then look at what I have here. All whole numbers, or all, excuse me, rational numbers. Whereas pi, being irrational, much like my thoughts on A, would go here because the period is not in terms of pi. This problem here, don't make it harder than it is. This is just something you're going to see in the future. It talks about the portion of a roller coaster ride as a sinusoid because it's basically shifted up. The top of the hill of the coaster is 125. You can kind of see that. It's going by 25s, 50, 75, 100. And then 25, 50, 75, 100. 25, 50, 75, 200. 25, 50. That's where they're getting that point. Okay. The lowest point immediately following it, this is 250. What it's asking here is, what is the midline of the wave? And we've talked about what midline is. Midline is halfway between the top and the bottom. It has nothing to do with left or right. I don't care about that. What's halfway between this point and that point? Well, let's just start counting down. Let's kind of waste time here. We got 25, 50. From the bottom, I'm going to go up 25, 50. Let's go down another 25, up another 25, and guess what? There is my midline. See how that did that? 25, 50, 75, 100, 25, 50, 75, 100 in each direction. This right there is the midline between the top and the bottom, the maximum and the minimum values of this sine. Sinusoid is the word actually. What is the equation of that line? Well, it is a horizontal line, so it is y equals, and it's, well, let's count it, 100, 125, 150. That's it. That's the equation. That's how I want to do it. Okay. Now, we've seen number 13 on the homework that we just got done with a little bit ago. And it said, now we're going to do a sine function, so I actually want a wave. Before, some people got creative, and that's cool, but on this one I want it to be sine. So I know this has to start at 0. I'm going to plot that right off the bat. Has a period of 0.002 seconds and an amplitude of 5. Well, 5 is up here, and -5 is down here. So I know that I'm going to touch the bottom and top here. Now, what a lot of people wanted to do is they wanted to put 0.002 here, there, and that gets, your graph is so skinny. Let's just work it out a little bit and make it so like every 2 is 0.05. Here's what I'm saying. if this is 0.001, so that's 0.0005, which I'm not going to worry about. What I want is 0.002 to be out there, and I'm going to do the same thing, go by 2's, negative 0.001, go by 2's, oops, sorry, can't count, right here. This is negative 0.002, and what do I want? I want there to be, well, if I'm starting at 0, think of sine as up, down, down, and up. So let's go. Up, halfway through, down, there's my 0, down, and up, right? Let's do the same but go in the other direction. So keep in mind, this is going to continue in that direction. So where do I need to go? If I'm going up, down, down, and up, and I go backwards, I'm going to come down here, back to here, back to here, and back to here. So from the very beginning, this is going to give me 2 rotations here, but I'm going up, down, down, and up, down, down, and up. Say what? Okay, so that's being silly. But hopefully you get it, okay? So the period is 0.002, so even if I measured from here to here, I should go 1, 2, 3, 4 sets of double boxes, okay? Now the frequency, remember the frequency, we said before, is 1 over the period. And if I give you the period of that, yes, 1 over 0.002 was the answer a lot of people had, but we can never have decimals and fractions. So either I move the decimal over 3 places and move it over 3 places there to get 1,000 divided by 2 to get 500, or I just take my trusty calculator and go 1 divided by 0.002, and guess what? I get 500 hertz, because it says that right here. Okay? That's it. Your homework is the next 2 pages. They should all look very familiar because they are all just like the notes, and they are in order. So in other words, the first couple of problems, okay, are just like what we did on here. I just want to find the amplitude and period and then write the equation, which you had to do, by the way, on problems on the 3rd page at the top. Here is like the graphs that we did on the top of, on the bottom of the 2nd page of notes. That's this section down here. Okay. This section up here is like what we did on the top of the page 2 notes. And then this is just like the problem that we ended with on the 3rd page. You're going to get all day, the 2nd day of these notes to work on this. So today is just notes. Tomorrow we're going to work on the homework. That way if you're absent, you know what's going on with this too. Have a good day.